Okay, so now we're going to put it all together. We've got all these rules that we've talked about. I don't remember how many there are, but usually there's about 8, I think. So we've got all these rules. We're going to put them together so we can simplify exponential expressions. So there's kind of some ideas here. First of all, if it's simplified, we're going to say there are no parentheses. Now, I'm going to say that's usually the case. There could be an example where you would have parentheses. But if you have something like x times 5x to the 4th, okay, that can be simplified, right? So, you know, it would be 5x to the 5th is what it would be. But even if you had like y times 5x cubed, you wouldn't write it as a final answer that way. You would write it as 5x cubed y. Okay, that's how you would write it. You'd put the letters in alphabetical order and the coefficient in front. Okay? All right. We're not going to have any powers to powers. No powers to powers. Those could be simplified. So if you get down to your answer and you have something like 5x cubed to the 5th y squared, well, you know, the 5 is okay, but that x, that can be simplified. So it's going to be 5x to the 15th y squared. So just you kind of want to check your final answer to make sure it's fitting this form. Notice both of them, coefficient in front, bases are separate with their own exponents. Okay. Also, you don't want the bases to be in there more than once. So let's say you do a bunch of work. So bases, I guess each base only once. Once in the problem. So say you do a bunch of work and you get like 5x to the 6th over x squared. Well, you've got a base of x there and a base of x here, so more can be done. 5x to the 4th. So this is like we're talking about having multiple steps, and how do you know when you're done? Okay? And also we don't want no negative exponents and no zero exponents. So let's say you have something like 10x to the 7th, y to the -2 over 5x to the 7th, y to the -1. Okay? And you're like all excited. You're like, okay, I know those rules. I know how to do this. I take the 10 over 5. That's 2. And then I subtract the exponents, 7 minus 7. And I subtract the exponents for the y. And then you get out your calculator or whatever you need, and you figure this out. And you have 2x to the 0, y to the -1. And you're like, oh, okay, I'm done. Well, no, because you have that 0 exponent. So remember this part, that's just 1. And you also have a negative exponent here, which is a problem. So maybe you take care of the 0. So you're like, okay, 2 times y to the -1. But we still don't want that negative exponent. So that's going to be 2 over y in this case. Okay, so that's just an example when you have a -1 exponent. I didn't know if we'd seen that before, but that's how you deal with it. Okay, so we have 4 problems to do where we get to practice this. So just take a deep breath, look at the problem, think about, well, what can I do? Well, I've got this outer exponent, right? 3. Sorry about that. I wanted to give myself a little more room to write. Okay, so I have an outer exponent. So how do I take care of that? Well, each base, the -3, the x and the y, they all have to get that exponent. So I'm going to have -3 cubed. I'm going to have x to the 4th cubed. Now, I probably would just put x to the 12th, but, you know, step by step, right? Okay. And y to the 5th to the 3rd. Okay, this is going to be the tricky part. I got to multiply that out. So -3 times -3 times -3, that's going to be a -27. And then I'm going to have x to the 12th, and I'm going to have y to the 15th. Now, I look at the problem. Do I need to do anything else? I've got a -27. Does that mean anything? No, because it's not an exponent. Okay, so this is done. I don't have any negative exponents. I don't have any zero exponents. I don't have any parentheses. The x is only there once, and the y is only there once. Okay, great. All right, next problem. So I look at what I have. I have stuff times stuff. I don't have any outer exponents, so I don't have to worry about that. I just want things to line up so I can multiply stuff together. So I want to think, well, what's the negative 7 times the negative 2? What's the x times the x to the 5th? And what's the y to the 4th times the y to the 6th? That's what I want to think about. Now, I probably, if I were doing this problem, I probably wouldn't write that out. I'd probably just do it. But, you know, again, step by step, you know, whatever works for you. We want you to do good. Okay, so what's negative 7 times negative 2 is 14. I have to remember that's x to the 1st, by the way. So that's going to be x to the 6th, because I'm adding those exponents, and y to the 10th. Did I ever have a power to a power? Nope, not this time. I don't have any negative exponents, don't have any parentheses, don't have any repeated bases. Okay? So again, it's following that format. Coefficient, base, base. Okay. So we have another one here. All right. We have division going on, so I'm going to have to do this division. All right, so I'm thinking, what's negative 35 over 5? I'll think about that in a minute. And then I'm going to go ahead and use the subtraction rule. I'm not going to do uptown, downtown this time. You could, but I'm not going to. All right, so I'm going to say x squared minus 6. Okay, that's the rule in division. You take the exponent on the numerator and subtract the exponent where the bases are the same, and you subtract the exponent on the one of the denominator. This is going to be y to the 4th minus a negative 8. Okay, now sometimes students are like, oh, I don't have to put the subtraction sign because it's already with a negative 8. No, you have to remember the rule. The rule is subtracting. 4 minus negative 8. Okay, so negative 7x to the negative 4. Remember, subtraction is not commutative, so 2 minus 6 is negative 4, and y to the 12th. Am I done? No, because I have a negative exponent. Okay, so I've got to move this downtown. So it's going to be negative 7y to the 12th over x to the 4th. Again, you could put that negative sign just out to the side if you don't like it that way. Now, if you're like, oh, I'm worried I'm not going to get that one right. That one's going to be a hard one for me, and sometimes these are. I'm going to redo the problem a different way. You don't have to be able to do them twice. The problem. You could say, all right, I don't like those negative exponents. They always mess me up. I just want to move this right away. So I'm thinking negative 35x squared y to the 4th times y to the 8th over 5 x to the 6th. So this is just another way to look at the problem. Okay, I do have to do that division and get negative 7. I could think about canceling. I'm going to cancel 2 of those with 2 of those. That's going to give me x to the 4th in the bottom. And then up here, I can think about combining those. Well, that's going to be y to the 12th. And then it's over that x to the 4th in the bottom. So, I mean, sometimes I like to do them that way. It's up to you. You just have to be able to do it right. A lot of these problems, there's more than one way to do them. Okay. Like this one. So I have a negative exponent out here, don't I? Okay. So what way do I want to do this? I don't know. I could teach you another little rule that would help maybe, but kind of what you can do is you can just reciprocate the whole thing. This is probably the easiest way to do it. And then make that a positive. Okay? Now, if you don't like that, you could think of it this way. 4x squared to the negative 3 and y to the negative 3. Okay, switch because, you know, you have negative exponents. So I'll make that y to the 3rd up here and make it 4x squared to the 3rd down there. You could do it that way. Or you could, you know, and there's more to do. I didn't put any boxes around anything. I'm not done with the problem. Okay, or you could say, well, let me just bring in the negative 3. That's what it seems like that's what we did on the other problems. Okay, so 4 to the negative 3, x squared to the negative 3, and y to the negative 3. So maybe you were thinking, I want to do it that way. Okay. I tell you, all three ways you're going to get the same answer. As long as you follow the rules, it doesn't really matter which way you start. You're going to get the right answer. Okay. So, well, I'll go this way. 4 to the negative 3. Yeah. And x to the negative 6. And y to the negative 3. Okay, now at some point everybody's got to move, right? Okay. So y to the third's coming up here. And then 4 cubed x to the 6th. And then y cubed. Okay, what's 4 cubed? I think we said that was 64. X to the 6th. Now this is a good answer. My bases, they're only appearing once. I don't have any parentheses. I don't have any negative exponents. I don't have any zero exponents. So I think it's good. Now the 64 is in the denominator, and that's okay. Would I get the same answer if I chose the other ways? Well, right here, I would have had the y cubed. The 4 cubed would have been the 64, and then the x to the 6th, which I think that's what we had. Oh, here's my other one. Right here, I would have had y cubed, and then I would have had to take that 4 to the third, which is 64, and then I would have had the x to the 6th. So they really would have all turned out the same. I'm not sure which way you like best. So there's more than one way to do these.